So hopefully people can see things and hear me. So this is going to be a talk about the serverless battle between AWS Lambda and Azure Functions. I thought the Mortal Kombat slide would be a nice one for this. So who am I? I've been a PowerShell user for something like 7 years or so. I have way too many side projects. I have a dashboard somewhere with all of my side projects on, but it's still missing some of them because I don't like going there to remind myself how many I have. I do a lot of work with Azure and AWS, currently as an SRE of sorts for a small company who want to replace Excel and Excel Online called Sage, who you might have heard of. I do have stickers, but obviously they're a little difficult to hand out at the moment. But I'll see what I can do for people. And as we'll no doubt be mentioned a number of times today, if you're not on Slack or Discord, please join Slack or Discord. We're lovely people who mostly don't bite. So the agenda for today is we're going to look at what is this serverless thing people keep talking about? Why would I want to use serverless? What do each of the platforms have to offer in terms of Lambda and functions? What areas do they differ from each other? How do I actually deploy my stuff into these places? What other things around Lambda and functions are there that can make them better? And why would you choose one over the other? So, serverless, unsurprisingly, actually has servers involved, regardless of what the name says. There's sort of 3 different types of serverless, 4 if you consider containers as well, somewhere in there. So you've got platform as a service, which is your things like your app services, and I just throw a website out and it's a thing. Functions as a service, which is the main thing I'm going to look at today, and then software as a service, which is like getting someone else to run your stuff for you and you just use the product. Technically sort of serverless because you're consuming a product, but not everyone considers it as such. Most of the time when people are talking about serverless, they mean functions as a service, but these other things are also types of serverless. And the further away from the servers you are, the better, because who really wants to manage servers in this day and age? So why would we use serverless? Yeah, you don't need to manage servers themselves or most of the infrastructure. At this point, I normally say how many people actually like managing Windows updates or Linux updates or anything like that. Even with things like WSUS and Config Manager, it's just a lot of hassle to patch servers every month or however often you want to choose to patch things. And even things like immutable infrastructure and stuff, it's all extra management you have to do with just managing things in a different way. So that's a big benefit of serverless as a concept. Elastic scaling is pretty useful. Usually pretty easy to configure, and it's the big benefit of the cloud that most people don't take enough use of. Most people end up doing lift and shift with some VMs in the cloud and not do the scaling thing. But that's where a lot of the benefits come in, because if in the middle of the night I don't have any traffic, why would I have my full fleet of servers deployed? I could just scale all the way down to 2 or 3 boxes or 2 or 3 instances or whatever I'm deploying, and then I'm paying a lot less money, which obviously means it's often cheaper overall. That's not entirely always the case with the cloud. If you have massive spikes in traffic and stuff, it might briefly look more expensive, but in a longer term, it is generally cheaper. So why would I use functions as a service, in particular as a type of serverless? Well, they're event-based workloads usually, and they don't require constant compute resources. So your functions are generally doing things based on incoming events and triggers, or sort of incoming in some cases. So if I've got something that responds to a web request, it doesn't need to be there all the time, or on messages appearing in a queue because that's some other service is processed. It can just spin up, do its job, and close down again in a very short period of time and just kind of do its thing. They end up with small single-purpose resources. So kind of like PowerShell functions, your average serverless function should do one thing and only one thing. So it makes them much easier to maintain. Means you don't get you're less likely to get scope creep, and they just kind of just do their thing. And if you need to chain them together, there's various orchestration options for that, and you can just pass things in and out of them. And they're usually ridiculously cheap. Both Azure and AWS offer a free allowance every month of how many invocations you can have, and I think for Azure it's like 1 million, and for AWS it's probably something similar. So like 1 million invocations is a lot. We did some maths on a previous company I was with, where we worked out we could run a function every 3 seconds and still have it free. So going from whatever that was going to cost us monthly to run to free might be saving a couple of quid, but it's actually a couple of quid every month, all of the time. So it builds up to a very big saving, and management love saving money because it means more profit for them. But also, if I don't have to manage the thing and don't have to patch the box and stuff, massive time saving for me. So my life gets easier, and I can do something else like chat around in Bridge and stuff. So let's have a quick look at what the different platforms offer. So first up, Azure Functions. There's a ton of data on this slide. I wouldn't worry too much about it. The main things are it's currently supporting PowerShell 6. 7 is on the way. I think it might be an early preview or something at the moment, or it was when I looked last week. So that's coming along. 6 is still pretty good. 7's nicer, but there's not a huge amount of improvements in a serverless world for the two. It's got a whole bunch of different types of triggers. You've got authorization in various forms and a ton of different outputs. The big things for most people using functions is things like HTTP triggers, timers, because then they can basically replace your scheduled tasks potentially, or your cron jobs, and things that use storage queues and service bus queues are quite cool. And the outputs are what you'd expect, dumping stuff into other queues and service buses, HTTP outputs if you wanted to call some other endpoints or some other function, so you can pretty much chain these together potentially. And yeah, they're pretty useful. So let's have a quick demo of this. Let's see if this works. So let's turn off Dark Reader because it's not going to work. Make this actually readable for people. Of course, Azure Function. The portal decides to refresh on the page on that. Makes sense. Right. So the PowerShell functions are PowerShell Azure Functions are supported in 2 versions of Azure Functions, version 2 and version 3. Generally, you want to be on the latest version of stuff. So version 3 has been around for a little while, and I believe it's GA now. So you should probably be using that. And this is going to die on me, isn't it? Let's do the old refresh the page thing. There we go. So I've got an HTTP trigger here, and it's pretty straightforward. All it's doing when it loads up is it will be trying to get some data out of Azure for me and return it as part of a request. I'm just using the Azure commands because they come shipped with this. So as you can see, the request comes in, and all I'm doing is just get me all the resources in this specific resource group, turn it into JSON, pipe it back out. If you can't do that for whatever reason, just tell me it's a bad request as if it was a normal web request. So I can hit run and run it. It'll take 20 seconds, 30 seconds, something like that, and then give me a big pile of JSON back. Obviously, this is a pretty simple thing, but because I can respond to web requests, I can do lots of things, especially if I can authenticate to Azure. I can have this triggering off my alerts. So instead of paging someone in the middle of the night, they get, this just happens. It goes, oh, I know what that alert means. That alert means I need to restart this web box. And this just goes off and does it for me. So that person now gets a better night's sleep. So as you can see here in this tiny little box in the corner, I got a whole big pile of JSON back, which is all the different resources available, which, yeah, not particularly useful a lot of the time, but as an idea of what you can do when you can authenticate with Azure from within Azure on a web request, pretty useful. So let's just jump back to the slides. So let's have a look at AWS Lambda. This supports PowerShell 6 and 7 due to how you publish things to this. That's a bit of interesting behavior there, which I'll go into. It also supports a whole bunch of different triggers. It doesn't natively support HTTP triggers. That's why I have to use API Gateway, but I'll come into that a bit later on. But again, huge different array of triggers. They have Event Bridge, which is quite an interesting way of having third parties trigger it from their own systems if they can't talk directly to your SQS queues. Same idea with functions. They've got a bunch of different outputs, a lot smaller list, but again, because you can output to Lambda or Event Bridge, you can often get to other things. And at the end of the day, you've got a bunch of PowerShell in here. So as long as you can make PowerShell do it, the Lambda will do it. So if you want to output to, like you want to send an email off to something, then you can just have the PowerShell send emails, which is one of the things I do with some of these Lambdas. One interesting thing Lambda does bring in is the concept of layers. So I can have my code as one layer, as like the base layer of the thing, and then dependencies as additional layers on top of that. So if I need to change my code that doesn't involve changing my dependencies, I can just update that, and those layers will always be available for me, so I don't have to worry about them. And it also means you can chuck stuff like random zip files and exes and whatever else you need for your code to run in there, and it'll just all be available to the Lambda as it spins up. So they're pretty interesting to play around with. So a quick look at a Lambda. So one downside of the Lambdas is the portal editing doesn't exist. There's literally nothing here you can edit with it, which has its plus points, but also has some minor downsides. So if I just pop open VS Code, which I should have done earlier. Why is this not? There we go. So if I zoom in a bit here, we can see really simple Lambda, not doing anything. It's literally taking some input and writing it to the host, because there's a few, like with Azure Functions, there's a few built-in variables that it uses for the different things that come in. And it uses hash requires to manage dependencies. So pretty straightforward. Lambda, write something to host. The important things with Lambda in difference to functions is that in terms of output, it only takes the very last thing that was written to stand it out. So if you write output things or just dump the variable in the pipeline, only the very, very last thing that goes into the pipeline is taken on to, pass back to whatever output you have. And if you write host things, it ends up in CloudWatch. So if we go to SQS, I have this lovely queue here, so I can send a message there to say this here, send the message, close that. It's picked it up almost instantly because it's watching that queue. And then if I jump over to CloudWatch and have a look at my logs, I can see my message came through and we have it there. And that's the input it got. And that ran in 400 milliseconds. So like that's not going to cost me any money at all, really. So that's pretty nice, very quick, and all running PowerShell 7. So it's pretty useful. So what are the big differences between the two platforms, since they both seem very similar? Lambda doesn't support HTTP triggers natively, as I suggested, as I mentioned. Requires API gateway, which is a pretty cool piece of tech, and allows you to like front up a bunch of APIs behind this, or a bunch of Lambdas, or anything else you want. And you can put some authorization in there as well with either AWS Cognito or a different Lambda to do that. But it's another piece of infrastructure you have to manage. So it's something to bear in mind if you want to do HTTP triggers in Lambda, but it also has its plus sides in that, you have one front end for everything. You can have multiple functions within a single function app. So as you saw briefly with the one I had a Cosmos DB trigger and an HTTP trigger. So I can have lots of different ones in there, and they all have one endpoint with / whatever my function's called on the end to trigger them if they're HTTP triggers. And they all get logged and billed, and everything runs in the same function app, which is pretty useful. Whereas Lambdas, you just have a Lambda or 50 Lambdas, and they're all individual resources that you have to manage. Generally, I would recommend you only have functions related to the same thing sitting in the same function. Just like you should only have Lambdas relating to that project or that account sitting in the same account. But you should be doing that with Azure as well, is that things relating to a project or a product should be in the same subscription as that. And you don't want to have things all over the place because it gets a pain to manage. Functions also has the big advantage that you can test them locally, because there's an emulator you can run locally that acts as if it was an Azure function. So you can do your HTTP triggers and everything else locally to make sure they work without incurring any costs randomly or running into any weird bugs that you might have accidentally left in and that's caused it to trigger 20 million times or whatever. So that's pretty useful. Lambda does have something similar, but it's only available for Node, Python, and Go. So that's not, none of those say PowerShell, so that's a bit of a problem. And while you can just run the PowerShell script locally, it's not really a proper test of what's going to happen when it's in the cloud. So it's sort of in the middle. You kind of get there, but maybe you need more testing. So once we've figured out what's the same, what the differences between the two are, what they look like, what they can do, how do we actually get our stuff there? An important point here is this is mostly from the perspective of I'm just doing this deployment for my testing stuff. If I'm deploying this to production, this is going into source control, this is going through an automated pipeline, and it's going through a proper managed way. This isn't just like me messing around in my own subscription. So as we saw, I can dev functions in the portal, which is nice and quick. If I'm just messing around with things very quickly, quite easy. I can do it through VS Code. There's a Azure Functions extension. It's very cool. Does a lot of scaffolding for you. Will publish straight to the Azure as well if you really wanted to. Again, primarily for dev in that sort of sense, but because it's in VS Code, you can put it straight into source control, which is useful. You can do it through the CLI, either using AZ PowerShell module or the AZ CLI. Both pretty solid ways to do it, nice and easy. There's a really, really hacky way to do it with ARM and Terraform. What you can do is you can hook up a function to source control, assuming it's a public Git repo, and it will just pull down whatever version is in master on a semi-regular basis and make sure it's there, or whatever branch you tell it. Generally, I'd recommend against this because unless you've got a good pipeline to handle PRs and stuff into master, that could be any old nonsense that's left in master at that point that's running. The even worse way to do it is that you can specify files and their content in line in an ARM template as part of the function deployment. So if you really wanted to, you could convert your PowerShell script to a JSON, to like JSON escaped single line string, and just push it out through your ARM template. If your function's 2 or 3 lines, that's probably fine. If it's 20 or 30 lines, that's getting really awful, and you definitely shouldn't be doing it this way in any way. It's just there if you really, really need it for whatever reason. So how does this compare to Lambda? Lambda's a bit more interesting with how they do their deployments. They have a module called AWS Lambda PS Core, and that's basically it. So the way this module works is there's 2 commands that you mostly care about. There is package and there's publish. The package does what you'd expect. It packages up your script, plus all of the dependencies, plus all of the stuff that's needed, like PowerShell 7, and it's some of the runtime stuff from PowerShell, and a little bit of funky other stuff that it needs to trigger that correctly, and zips it all up, which is great. And then publish does the same thing, but pushes it into Lambda for you. And because of this model, it's meant that as soon as Lambda supports the .NET Core version we need for PowerShell 7, and the module gets updated, you can basically push straight into Lambda with PS7 with like no dependency on the Lambda team doing the work to support 7, because they support .NET Core 3 or 3.1 in this case, and 7's built on that. The other big advantage of this method is that it means you've got a consistent model between how I do it on my dev machine to push to a dev environment and how my CI/CD pipeline does it. So the alternative option you've got, which uses this, is you can sort of do this with CloudFormation, because what you can do is you can use the package command to zip it up. You then push that into S3, and then CloudFormation has an option to say, okay, deploy me a Lambda using the code that's in this S3 bucket called this file, which is great. Just be very careful if you do that you name your zip file something dynamic. So call it my Lambda dash a git hash. Because if you don't, if it's always called the same thing and you deploy your CloudFormation template again, Lambda just goes, nothing's changed with this. Well, CloudFormation decides that nothing's changed with the template itself, so it has nothing to do, even if the code sitting behind the scenes has changed. So yeah, you need to have that as a bit dynamic, otherwise nothing changes. And that caught me out for a little while. Which is kind of an annoyance, but that's it's my own fault for not looking into it a bit more. So what else is there? So around Azure Functions, we've got a whole bunch of stuff. Like obviously we've got the entire of Azure, which is quite a lot of things. I'm not going to list everything, but the main things we want to look at is things like Azure AD. Pretty useful. Does all of your authentication these days if you're on-prem and moving into the cloud. And because of the way functions work, you can give them a managed identity, and it can then authenticate against Azure for you. So you can do, like I was mentioned earlier, you can have it responding to your alerts and interacting with your Azure environment for you, which is obviously pretty useful for alerting or just generally querying things that are in Azure. Application insights. I haven't seen a single similar tool in AWS that does this or integrates so nicely with everything, but it will do all of the monitoring and reporting and tracing and everything else you might want to do for basically no effort. You put in a key for it, or you press a button that says integrate application insights, and it just does it. So every run of your function logs a whole bunch of stuff to App Insights, gives you tracing, tells you what other resources it talked to, how long they took, errors, basically everything. It's really, really, really good. And the query language in it is powerful, if a little frustrating at times, because everything's a comprehensive, complex event. You can do some really cool querying on it, which is kind of like SQL, but not quite like SQL. And there's some libraries written in C# or .NET, I guess, that you can then leverage to write custom metrics and stuff to the App Insights, which is pretty handy for if you've got some custom logging you want to do. The other useful thing is Key Vault, because we've all got secrets that we need our pipelines, our functions and stuff to use, because maybe it's talking to a third-party system, or the identity it runs as doesn't have the permissions it needs to talk to like specific parts of Azure AD or other subscriptions or something like that. So Key Vault is where you shove all of your secrets. And again, because it's managed, the function can run as a specific identity. You give that identity access to the Key Vault. You give it get access, not a list access, and then it runs. You give it get because then it only gets the secrets it needs and knows about. If you give it list, it can figure out what secrets are there, and you want to limit the amount of potential options for malicious attackers. So the last thing that Azure has that's really cool, or at least relating specifically to functions in this case, is durable functions and logic apps. So logic apps is kind of like the orchestration tool of choice in Azure. You give it a bunch of steps, it runs through them based on input. Again, it has different types of triggers. It can trigger different things. It has different connectors. It's pretty good with what it can do, what it can integrate with. And it means like you don't have to have long running functions. You can just have this trigger the function, and then it waits for the function to finish doing its thing and return some data if it needs to, or like occasionally pulls the function if the function's doing like async stuff where the function itself talks to a third party. Durable functions are kind of a similar idea in that they're ideally meant for stateful functions and long-running functions, but the PowerShell support at the moment is experimental, so not entirely an option unless you want to write C# or wait a while for the experimental support to go to public preview. So what does AWS have? It's got System Manager Parameter Store. This thing is really interesting. It's kind of like Key Vault in the sense you can store secrets there, but you can store a bunch of other different data types there, just like plain old strings. So that's pretty cool for dumping configuration you might want to change on between runs or without necessarily redeploying your Lambda. So because you can store strings, you can store JSON. And because JSON is pretty useful, you can pull that down to PowerShell and do stuff with it. So one example of that is we've got a bunch of stuff in Azure, and I want to pull stuff out of application insights and push them into another third-party system to try and like centralize everything. So I've written a Lambda that will talk to App Insights, but I don't know which App Insights to talk to. I don't have the authentication to do that. I don't have any of the things I need other than this bare bones Lambda. But what I can do is I can trigger that Lambda with specific messages, like saying, run for product A. And the Lambda will talk to parameter store, pull down the settings that are relevant to that product A, and then do its thing. So it'll figure out what App Insights it needs to talk to, figure out what queries it needs to run against that, what data it should be returning, and then do its job. But then the next run, it may be talking about product B, product C, and so on. So it gives me a lot of flexibility in how I write my Lambdas and my functions without having to maintain one Lambda per product I want to talk to. I can just maintain one and a bunch of JSON files. So that's quite nice. So API Gateway, I've mentioned this a few times. It gives you a nice single point of entry for one or more Lambdas or a bunch of other different services you can hide behind it. It lets you do authorization and authentication on that layer if you want to do that as well. It lets you do throttling. It lets you do a bunch of other stuff on it. So it's what you'd expect out of an API gateway, but you just like hook up a bunch of Lambdas and other stuff behind it. And I believe that's got a weird, interesting costing model because AWS likes to do weird and interesting costing models for some stuff, but it's still a pretty useful service to have. The IAM service, which is Identity Access Management. Kind of similar idea to what Azure AD will do with RBAC for its role-based access control, but I find this a lot more granular. So if I want my Lambda to talk to an SQS queue to pick up its messages, I can say, you can only talk to that SQS queue. And then I can say, okay, I want you to talk to parameter store, but you can only talk to parameter store for parameters that start with your name dash whatever. And then it'll all pick up stuff related to itself. So you can do a lot of really interesting stuff with that to really limit what your Lambda can do. And because it's configurable through CloudFormation, you can have this all documented alongside your Lambda, which you deploy at the same time. So it's nice and easy to see what it should be able to do. And if people change it, then CloudFormation will fix it for you when you do your next deployment. And just like Azure has logic apps, AWS have step functions. Same idea. I have a bunch of steps I want to perform, which might involve triggering a Lambda, waiting a while, triggering the Lambda again with some different input to figure out what's going on, talking to other services based on whatever different input I've got. So step functions are really cool for that. And again, you can hide those behind the API gateway so that although a user might think, oh, I'm triggering /respin that box, what's actually happening behind the scenes is the step function is going, okay, spin me out a new box. And then the step function waits, and then it triggers again, goes, okay, spin me out and like kill off that old box, that sort of thing. So it's quite useful. Again, very much like logic apps. So why do we care? Why would we want to use Azure Functions? Or I guess Lambda on the next slide. Important thing here, when I'm considering these things, is I'm obviously skipping over the fact that if you're just in Azure, you will use functions. Or if you're just in AWS, you'll use AWS. Or if you're in GCP, then you use whatever GCP have. If you're not, this is mostly for the point of view of people who are either multi-cloud for a variety of reasons, or who don't have any cloud yet because they haven't caught up to the real world, or have whatever security issues and whatnot. So they have easy creating HTTP triggers because they're just there out of the box. HTTP and timer are probably the biggest two triggers you will use, at least when starting out with functions. So having them there out of the box and not having to maintain an API gateway is a massive benefit. Makes my life a lot easier with having to manage these things. They have a wider range of output options. Now, while you can get the PowerShell script to do whatever you want in terms of output, if I have to send emails or whatever, having those built in means I don't have to write that code. And therefore, I don't have to write bugs into that code. It's just all there, bugs and all there, but it works. And it's tested by a lot more people than me and a couple of guys on my team for testing it. Poshbot uses them. This is kind of not necessarily a benefit of Azure Functions, but if you're using Teams and looking at chat ops options, then Poshbot's really good and can use functions to do the Teams integration. I keep thinking I should roll the Lambda version of it as well at some point and template that out and add it back to Poshbot, but I haven't had a chance yet. So it's a bonus point, I guess, for functions in that if you're running Teams and want chat ops, you'll basically start using them anyway. So why would we use Lambda? The parameter store is really, really good. Like, it saved me a ton of effort in terms of maintaining a lot of Lambdas that do the same thing, just slightly differently for different products. So that's pretty nice for my life as far as I'm concerned, and I can keep it all maintained in source control and stuff, and it saves a lot of effort in maintaining a dozen Lambdas. And there's a lot of options. You can store your secrets and stuff in there, so it's quite a nice feature. You have a consistent deployment model. So while functions are great and that I can deploy them in like a half a dozen different ways, the fact that I can only deploy a Lambda in one way means that if my deployment from my dev machine to Lambda fails, I know it will also fail my CI/CD pipeline because I'm using the same thing, or it's probably going to fail for the same reasons. So you're getting a much more, you're testing your CI/CD deployment model in the same way by just doing normal dev work. So who's the winner? Because that's the important part in this. And I want to take the sneaky get out of jail free card option of saying both. Like they're both really, really good platforms. They both support PowerShell. They both have a lot of flexibility. They both scale. They're both basically free, assuming you're not doing more than 1 million invocations a month, which like is a lot. That's what in a minimum of one every 2 seconds or something like that. So that's quite a lot of invocations to hit that free limit on at least on Azure. On AWS, I assume it's something similar. And as long as you're doing event-driven automation, they're really good. So take whichever one's in the cloud you're using. If you're doing multi-cloud like we do, then use whichever one's in the cloud of the product you're doing automation against. So if my AWS services, I will use Lambda for the stuff that's sitting in AWS. If I have to pick between the two for just some generic stuff that's not related to either, I don't know what I would pick in that case. Probably whatever my team is most comfortable with. And I think most of our stuff, my team's stuff is in AWS. So I probably end up with using Lambda just so it's all in one place. But yeah, take the cheaty option there for what the winner is. And that's everything. So my slides are up on my GitHub, or these will be very soon. Again, if you're not on Slack or Discord, join us on Slack or Discord. And my Twitter handle's there if you want to follow me for my occasional random posts on that. Normally I'd ask if there's any questions, but I don't have Twitch